Section 2.4, Polynomial and Polynomial-like equations in one variable. In this section, we are going to solve quadratic-like equations, general polynomial equations by factoring, and polynomial-like equations by factoring. For an equation that is called quadratic-like or quadratic in form, it is in the form of a times the quantity a squared plus b times the quantity a plus c equals 0, where a, b, and c are real numbers and the coefficient a is not 0. The quantity a is an algebraic expression. And to solve a quadratic-like equation, we use the method that is called the substitution method. By solving for a and then solve for the variable in the expression a. Let's look at the examples. For the first one, we are going to solve the quadratic-like equations. In part A, we have the quantity is x squared minus 7 squared plus 7 times the quantity x squared minus 7 minus 18 equals 0. In this case, we notice that we have the quantity x squared minus 7 power 2 and quantity x squared minus 7 for the second term. First, we're gonna let a or the expression a as the x squared minus 7. So then the equation becomes a squared plus 7 times a minus 18 equals 0. At this point, we have the quadratic equation. And then we're going to solve this quadratic equation by factoring. The leading coefficient is 1. So the strategy to solve by factoring, we're going to look at the two numbers that the product is negative 18. That means one quantity is negative inside, the other quantity is positive inside, where the sum of these two numbers equals 7, which is the middle term. Now we look at the two numbers, multiply to get 18, but opposite inside. That would be positive 9 and negative 2. Recall, if the sign of the sum is positive, so the larger quantity would have the same sign as the sum. Now back to the problem. That means this expression can be factored as a minus 2 multiplied by a plus 9 equals 0. After that, we are going to solve for a. The first expression or the first factor, we have a minus 2 equals 0. The second one would be a plus 9 equals 0. Solve for a. The first one, a is 2. Second one, a is negative 9. The original variable is x, so then we're going to solve for x that is within the expression a. Recall expression a is x squared minus 7. So at this point, we are going to replace a with the x squared minus 7 and equals 2 for the first one. And then x squared minus 7 equals negative 9 for the second one. The first one, solve for x, we have x squared equals positive 9. That means x equals plus minus square root of 9 or plus minus 3 by taking the square root technique. Okay. For the second expression, the second one, we have x squared equals negative 2. That means x equals plus or minus square root of negative 2, which is plus minus of the I times square root 2. In summary, the solution for this expression is this equation is x equals 3, negative 3, I square root 2, negative I square root 2. For the second one, the equation is y to the power 1/2 minus 8 times y to the power 1/4 plus 15 equals 0. As you notice, the first one, the power is 1/2. The second term, the power is 1/4. 1/2 is twice of 1/4. So we can rewrite this expression on the left side as y to the power 1/4 quantity squared minus 8 times y to the power 1/4. And we just treat the same way as we see y to the power 1/4 as one quantity plus 15 equals 0. For this problem B, we're gonna let A, or the quantity A, be y to the power 1/4, and then replace it or substitute into the equation or the expression on the left side. Now we get A to the power second minus 8 times A plus 15 equals 0. At this step, we have the quadratic equation with the leading coefficient 1. And then we're going to factor for the value 15, which is the C here. We're going to find the pair of the numbers that the product is 15, but the sum is -8. If the sum -8, that means both of them would be the same sign because the product is positive. So then the two numbers that we could think of would be -5 and -3. Back to the problem, we're gonna get the two factors as A minus 5 times A minus 3 equals 0. We get A equals 5 for the first one, A equals 3 for the second one, and then substitute A with the y to the power 1/4. So y to the power 1/4 equals 5 for the first one, and y to the power 1/4 equals 3 for the second one. To solve for y, so we're gonna raise both sides to the power 4 to have y to the first power. We have y equals 5 to the fourth, which is 625. And the second solution, y equals 3 to the fourth, which is 81. Therefore, the solutions for this problem is y equals 625 and 81.